Okay, in this example, we'll be looking at how to graph the function f of x equals to 3 to the power of x, and in this case, the base is 3. So it's going to be a little bit interesting because as soon as I see the base is 3, I can basically automatically get certain information about the function. Okay, so having a base that's more than 1 automatically means that my graph is going to start very small and it's going to shoot up very, very quickly. So I get all that information from kind of just knowing that the base is more than 1. Okay, to make the graph, we will be using the table technique again. And so again, here we go. In this case, the function is 3 to the power of x. And in the first table row, we're going to be replacing x with -3. And so that's going to be 1 over 3 cubed, which is 1 over 27. Again, how did I get this? Negative exponents just means that the thing should be upside down, and 3 times 3 times 3 is 27. That's how I got the 1 over 27 at the very, very end. By the way, 1 over 27 is something very, very small, okay? And what about -2? So again, just like before, I'm going to take the 3, the base, and replace the power exponent with the -2. And again, because they're suggesting to put -2 in. And so what is 3 to the power of -2? Just like with the -3, 3 to the power of -2 is going to be 1 over 3 squared, which is 1 over 9. So again, it's something very, very, very small. Now, what about -1? 3 to the power of -1 is going to be 1/3, which is about, roughly speaking, 0.33. And when x is 0, I get 3 to the power of 0, which is basically 1 at the end. So far these are my values. What about 1? 1 gives us 3. What about 2? 3 squared is going to be 9. Then finally 3 cubed is going to be 27. So notice how the numbers went from being very, very, very small at the start to being very, very, very large at the end. Okay, so at this point we're going to take these numbers and plot them. Let me start with the 3. When x was 3, so this is 1, this is 2, this is 3. The y was 27. It's like way up here, like outside of the grid. So you know what? I'm not going to be able to use that point. So even though it's good and everything, it's way outside of my grid, so I'm not going to even pay attention to it. What about 2? 2 gives me 9. When x is 2, the y is going to be pretty much over here, 9. So this is the point 2 comma 9, which is very, very high. Okay, the next one is going to be 1 with the 3. When x is 1, the y became 3. So when x is 1, the y became 3. Next we have the 0, 1. So 0 gives us 1. That's right there. So 0 gives 1. And we get into the small ones. So when x is -1, the y is 1/3. So kind of like over here. -1 gives me 1/3. Okay. So -1 gives 1/3. And when x is -2, we get 1/9, which is over here. And it just keeps getting smaller and smaller. It never touches the x-axis. It just gets smaller and smaller and smaller. So the next one is going to be 1 with, the one with the 1 over 27. So in any case, the graph is going to look like it starts very low and it just shoots up very, very quickly, very high. Okay. I don't like how that looks, so let me redo it one more time. Here we go. So that's the general shape of the graph. Okay. Keep in mind that the x-axis is an asymptote, so there's a dotted line right here that you cannot cross. That dotted line has the equation y equal to 0. It's what we call a horizontal asymptote. It's kind of like a horizontal line that looks like a border, basically. And so in the future, if you want to graph this problem, you don't have to do all these steps. There's too many steps to make. It's too much, the table is really huge, and really we end up not using these 3. They were like all very, very small. So in general, what you want to do is basically build a table that has the point 0, 1 into it, and it has the point 1 comma the base. So that's what we noticed so far. We did the first problem earlier, we did this problem, and both of them pass through the point 0, 1 always. So that point always belongs on the graph, for sure, 0, 1. And you can see right here, we passed through 0, 1, that was a point 2. And we also pass through the point 1 comma the base. So whatever the base is, that's always going to be the point. So 1 comma the base, and the point 0 comma 1 will always be on your graph no matter what. So earlier the base was 2, and notice that was the point right there, 1 comma 2. So with those two, you can pretty much get the general graph, and you'll be able to complete the rest for free.